some presynaptic receptors. We're talking about autoreceptors. There we go. They're feedback loops. So they detect the neurotransmitters when they enter the synaptic cleft. And they're responsible for modulating the release with mostly a negative feedback. So it senses, okay, I have some neurotransmitters binding to me. I'm going to do something to stop snare from releasing the vesicles. Or maybe they close ion channels so that the calcium is no longer flowing in, and do it that way. And then there are a couple different, maybe they're not looking at the neurotransmitter itself, but looking at external chemicals that are floating around between the cells, or other things like nitric oxide. Or maybe these are byproducts from breakdown of neurotransmitters, so they would know that they need to uptake more. And then a couple of these neurotransmitters are sent out by the modulatory systems of the brain to help increase activity or decrease activity. So norepinephrine is this green line, so it's sent out to multiple areas of the brain. So it goes to the thalamus, the hypothalamus, neocortex, cerebellum, down the spinal cord, and norepinephrine is involved in regulation of all these things: attention, arousal, sleep-wake cycles, learning and memory, anxiety and pain, mood, and metabolism. Another system looks a little more complex: serotonin, which also active in arousal and sleep-wake cycles. And this is released from a couple different nuclei in the brainstem, and again goes to the thalamus and the hypothalamus, but also goes to the basal ganglia. It looks like more areas in the cortex and down the spinal cord. So again, you're regulating these things, maybe not through a neuron, but now you're changing how much neurotransmitter is in those synapses, those clefts. LSD reduces the activity of this system, and you can actually treat depression by limiting their reuptake, so how quickly they are gotten out of the synaptic cleft. So they stay in the cleft longer, so maybe you have more arousal, so you're awake more. Another system is dopamine, which is a lot smaller system. It's released from the substantia nigra, goes into the striatum and the frontal lobe. And this is involved in voluntary movement, or initiation of voluntary movements. So waking up. And also, it goes into areas involved with reward. So cocaine is a dopamine reuptake inhibitor. So if the dopamine is in the synaptic cleft, it's going to stay there longer, giving you more reward. Where speed causes the release of more. So instead, maybe the cells are getting rid of it from the cleft the same way, but more is being released. So you have, in general, more in the clefts activating these pathways. And acetylcholine is again involved in arousal and sleep-wake cycles, and another similar pathway, and is involved in producing cortical oscillations. And these cells are, in the basal forebrain complex, are something that died during Alzheimer's. So they're involved in memory and learning. So if you don't have this basal forebrain, so if you don't have it being produced, then you're going to have issues with memory and learning. Or if you don't have it being used correctly, you're going to have issues.